parallelogram, that is to input and output. Diamond, decision making or controlling also you can say. Arrows, flow of control. Flow of control. These are the basic things which we need to draw the flow chart for a particular algorithm. Let's an example of these two questions. Here, first step is start. We are making an oval, that is start. Second step is input two numbers. For input we have parallelogram. Now we'll just design a parallelogram. Input two numbers. Add both numbers. That is the process. For process we have rectangle. Sum number 1 plus number 2. Print is output. For output we have parallelogram. Print sum. And the last one is stop. Fifth step, stop. First stop. This is the flow chart and this is the algorithm. This is flow chart and this is an algorithm. For this, if we are writing a program in these ways, we also can write here. There is no need to long spaces also. Step 1, that is start. Step 2, define. Define is the process. If you are going to define a variable or declare a variable, declare, you cannot say define, that is declare. Declare a variable. Then declare a variable means you are going to declare a variable and that is under process. Declaration is the process. Under process we can write number 1, number 2 and sum. These are the three variables. Input two numbers, just write parallelogram. Input two numbers, number 1, number 2. The next one is add both numbers and store the result in sum. Add is what? Add is the process also. Then the process is sum is equal to number 1 plus number 2. Variable can be anything, number 1, number 2, A, B, C, X, Y, Z, whatever. And the last one is, the next one is print. Print is parallelogram. Print sum. The last one is stop is there. So guys, this is how we can write basic and smallest algorithm and flowchart. I hope you will able to understand the things. Whenever you are getting any difficulties, you can mail me. I'll reply for your question. I'll try to solve your problem also. We are facing in very crucial time, and that's why we are going to do such a work to help all students. Okay. Now, let an example of another one. I'm going to erase it. This is to find the sum of two numbers. But now we are taking another program, an algorithm to find maximum in two given numbers. Which is the largest and which is the smallest one? This is according to control structure. Step 1, as you, I think you will be able to understand what is step 1. Step 1 is start. Step 2, declare variables. A and B, suppose A and B. Step 3, input two numbers, that is A and B. Step 4, under step 4, check if A is greater then print first number is greater, otherwise print second number is greater. Step 5, stop. In this way we can write controls program. See, step 1 start, flowchart is there. Start. Second one, declare variables A, B, input two numbers A and B. Check. For checking. Checking is what? Decision making. If you because you are going to make your decision, which one is greater and which one is smaller. Greater. Then B का लिख सकते हैं हम. Decision making. If A is greater than B, if yes, here if A is greater than B, yes, then print first number is greater. If no, print is greater. In both the situations, we will go to stop. Either in this way or either in this way. These are the steps to write algorithm and flowchart to find greater between two given numbers. Let another example. Write an algorithm to print 1 through 10. One, two, you can say not 10, n can be 10 or whatever your requirement is. Step 1, start. Step 2, declare variable that is start point s is equal to 1, because we have to print from 1 to n. So 1 is the starting point, we are taking s is equal to 1 and n is there. Step 3, input value of n. Step 4, print s. Under s we have 1. Now 1 is printed by the particular algorithm. After printing, means we have to go from 1 to n. Suppose n is 5, then we have to print first 1, then 2. 2 is what? Increment of 1 with initial value 1. So increment is there. So then step 5 says increment s by 1. It means s plus plus, you can say s is equal to s plus 1, you can say s plus equal to 1, you can say. We'll study further what is the use of this one. All three things says increment 1 with s. Step 6, under step 6, check if s is less than or equals to n. Repeat. Step but printing. Step 4 and 5. If s is less than or equal to n, repeat step 4 and 5. Step 7. See, s is equal to 1. Here s is equal to 1. Suppose we are inputting n is equal to 5. Print s. S means 1. 1 is printed by this fourth step. Now increment s by 1. Now s becomes 2. S becomes 2. Check if s is less than or equal to n. S is, yes, s means 2. 2 is less than or equal to 5. Yes. If yes equal to n, if s is less than or equal to n, then repeat step 4 and 5. Just it is going to 4, and 4 is what? Print s. S means 2. It is printing 2 over here. Then again increment s by 1. S becomes 3. S is less than or equal to 5. Yes, it will print 3, 4 and 5. After printing 5, it will become 6. And it will check 6 is less than or equal to 5. No. Then it will go to the next step, that is stop. This is how we can print 1 to n. Now, flowchart for this one. Start. Step 1, start. Declare variable, as we have already studied. Declare variable means s is equal to 1, n, input n, input value of n, print s, here print s, increment s by 1, s is equal to s plus 1, increment s by 1, check s is less than equal to n, If yes, repeat step 4. If no, no. Stop. We can write algorithm and flowchart in such a manner. This is how we can print 1 to n. Now the rest 2 questions, which is very important for the program examination, very important for the examinations, are find factorial of a given number and Fibonacci series. Fibonacci series is one of the most important questions if you are appearing in BCS, BTech, to examinations also. This is the most favorable question by teachers as per the entrance stage. As you are in the early stage of writing programming, you should must understand these 2 questions. Algorithm to find factorial. First of all, we should know the theory of factorial. Factorial is denoted by 5, this one, and it is 5 into 4 into 3 into 2 into 1. This is, it means factorial of 5 is 120. We have to find this one. See here, 5 is the number given by user to find factorial, and 5 is going to multiply itself with the value which is smaller, 1 is smaller than itself. It means it is going in a decreasing manner. 5, 4, 3, 2, 1. It cannot be 0 because multiplications. One thing you should must remember, whenever we are adding continuous numbers, whenever we are multiplying continuous numbers, there are 2 processes. If you are adding, you should must take a variable with 0 because 0 cannot change any value after adding it, and 1 cannot change any value after multiplying it. So you should must remember, whenever we are going to multiply again and again, you should must take a variable with 1, and whenever you want to add again and again, you should must take a value with 0, a variable with 0. Here 5, we have to find the factorial of 5 or n, whatever. That can be n. Factorial, let n. I'm going to find factorial of n. N can be 5, 7, whatever. Step 1. Step 1 is start. Step 2, this is declare variable let f is equal to 1. We have already discussed, whenever we wanted to multiply again and again, we should must take a variable with 1, and n is there. I'm taking only two variables, that is f and n. Step 3, input n. Step 4, factorial using f is equal to f into n. Step 5, decrement n by 1. Decrement n by 1. Step 6, if n is greater than or equal to n is greater than or equal to 1, then repeat step 4 and 5. It will go until n become 0. See how it is possible. Let f is equal to 1. According to this algorithm, f is equal to 1. N is what? N. Let n is 5. Calculate f is equal to f into n. F is equal to f into n. That is 1 into 5. That is 5. Now f becomes 5. Decrement n by 1. N becomes 4. N is greater than or equal to 1. 4 is greater than or equal to 1. Yes. Yes. Then go to step 4. Under 4, what is there? F is equal to f into n. Under f we have 5 and 5 into 4. It means what? 20 is there. Here is 20 in f. Decrement n by 1, it becomes 3. N becomes 3. And now check 3 is greater than or equal to 1. Yes, then it will come into this way, and 3 into 20 is 60. Then decrement n by 1, n becomes 2. Then 2 is greater than or equal to 1. Yes, then it becomes 120. F is equal to 120. Now n becomes 1. Greater than or equal to? Yes, it will become 120. Now it becomes 0. N is greater than or equal to 1? No, because it is 0 now. So then go to step 7, that is stop. Just take it, learn it, try to write your own programs and flowchart also. See the flowchart of this one. Start, declare a variable, that is f is equal to 1 and input n. Calculate is the process. F is equal to f into n. Decrement is also a process. N is equal to n minus 1. Check n is greater than or equal to 1. If yes, go to calculate this one. Otherwise, just print f, then stop. We can write algorithm in this way. This is the algorithm to find factorial of a given number, or factorial of n. The next one question is for you, and that is find. So I'm going to tell you about the process of writing the algorithm. That is algorithm to write algorithm for Fibonacci series. Now your work is algorithm to generate Fibonacci series. That is also Fibonacci algorithm to generate Fibonacci series. We must draw flowchart also. That is important for your examinations. How the Fibonacci series comes up? Basically, there is a story, but we are going to tell you. Fibonacci series is 1, 1, 2. You can say 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. How it becomes? 0 and 1 are the two initial values. Sum of 0 and 1 is 1. 1 is derived from sum of 0 and 1. 2 is derived from sum of 1 and 1. 5 is derived from sum of 2 and 3. 8 is derived from sum of 3 and 5. Okay. Sum of 5 and 8 is 13. Sum of 8 and 13 is 21, and so on. It means there are three variables. Let A, Fibonacci 0, Fibonacci 1, and Fibonacci 2. At the stage, initial stage, we have Fibonacci 0 is 1, 0 is 0, 1 is 1. Then what is F2? The answer is Fn is equal to Fn minus 1 plus Fn minus 2. It means sum of last two numbers are the next number. So F0 and F1 becomes plus sum of F0 and F1 becomes F2. Now F0 becomes F1 and F2 becomes F1 की वैल्यू F0 में आ जाएगी और F2 की वैल्यू F1 में. Again we'll add this one and we'll get 2. Same way F0 is swapped with changed by F1, then F2, 3, 2, 3, 5, 3, 5, 8, 5, 8, 30, and so on. You have to write algorithm and flowchart for this program. Now next topic is top-down design. Or it is also known as stepwise refinement. Stepwise refinement. Top-down design or stepwise refinement. What is top-down and stepwise refinement? Basically, whenever we are going to solve any huge, large or complex problems, you can say any complex problem is needed to split into smallest problems or sub-problems. It is easier to solve it out. Whenever we are going to solve any large or complex problem, we need to split the particular problem in a small sub-problems. And after getting all small sub-problems, we solve it individually, and then we can combine it as a whole result. It is called top-down or stepwise refinement. As whenever we are working in any manner, let's say we have two manners to solve any problems. That is top-down design and bottom-up design, bottom-up approach. We have two approaches, that is top-down and bottom-up. In top-down design, suppose we have a complex problem. That is a complex problem. you can say large problem. How can you solve it out? We'll split into sub-problems. That is sub-problem. A large problem can be split into many sub-problems. After going in many sub-problems, you can say if you are doing any project, that is the module of the particular problem. A project contains many modules, but everybody is not able to work on each and every modules. So we have a team to work on individual modules. And these are the modules. 4 modules are there in a particular problem. It is very difficult to solve by a particular team, so we have given it into 4 teams. And now it has many subroutine and functions. Many solutions. Solution 1, function 1. Function 1. Solution 2. Function 2. And so on. Solution n. Function n. And after getting solution from all those parts, we have combined it together. Combined it together is a complex solution. The top-down design is what? A complex problem is divided into sub-problems. Sub-problem has sub-solutions, and after getting each sub-solutions, we can combine it together and put it as a complex solution. This is called step-by-step refinement, stepwise refinement or top-down design. This one is very important for you all.